So this is for step number 5. Does that sound right?
Yeah.
Okay. And this is the generic 4-step process for a 1-sample hypothesis test for means. And this is number 5, and we are in chapter 9. So how is that different than last chapter? It's a hypothesis test as opposed to an interval. So it actually is still going to be a ZT. I don't know why I don't write it there. All right, so let's think through your homework. What did you have to do in your homework? Null and alternative. What else did it ask you to do? Define your parameter. And what is the thing that I just talked about in addition to what the homework asks for? I talked about something that I didn't want you to do with the homework because it's going to be weird sometimes. Defining your population. So we're going to define our population. Why did I not write out my population last chapter? Did I just not talk about my population last chapter? What did I do instead? I defined it within the statement itself. We're just separating it because we have more things to deal with now. I don't know.
Okay.
Yeah, no, I don't know.
They look okay.
I have only gotten through the first 2. Once I get time to sit down, the next ones will go by quick. But because I had everything scheduled for the test Friday, and I moved it, I haven't got a chance to look at it yet. But once I start, they should go pretty quick. So we've defined our population, now we're defining our parameter. So since we're only dealing with means, we're defining mu right now. So my first word of defining mu should be what?
B.
So last chapter, we just basically wrote a sentence that included both of those things together. And just because we're starting to have more pieces, I just choose to write it separate at this point. And because before we had to write a sentence that said like what we were trying to estimate, and we don't have to do that now, so there's no reason to write a sentence if we don't need to. And then the main part of the homework, the first thing I'm going to write is H what? H sub 0. Well, because I'm only dealing with these, what's this first symbol going to be? This is always going to be equals, and then I'm going to pick a number. And let's go ahead and write units 2. And then what's going to go underneath this? H sub A. What do I know is going to go right here? And then I know this is not going to be what? It's not going to be equal. What are my 3 options? And then my same number. My same number, my same units. If you want to, you can put an arrow down so it's showing that it's the same thing. That's gonna seem weird right now, but we call this number mu naught. But I don't care if you write that or not. It's the value of our null, the value of our claim. So like if the claim is a score of 80, then your null mean would be 80. It's mainly for later when I reference that. And then the last one is the part that we didn't really talk about yesterday. Let alpha equal some number. So alpha in general is how rare is rare for me to overturn it. So if it happens, like the first example we did was with the guy running, and that scenario would have happened about 15.87% of the time. And we said, well, that doesn't seem like it's so unlikely that I would walk up to him and, tell him he's a lie. But at what point do we overturn? That's what alpha decides. For the sake of our class, we are going to use 0.05 if one is not given. So in most scenarios, we're going to think about things as if it were going to happen and it would happen less than 5% of the time, that's enough evidence to overturn it. And we barely touched on this yesterday, but we'll get into a lot more conversation about that with obviously different scenarios are going to want different levels to be able to overturn it. So technically, yes, this looks very different than what we did before, but it's because this was written in a sentence together, and now we have null and alternative hypothesis instead of we want to. Plan. What is my first step of plan? Well, what do you think it's going to start with? What decision did I have to make at that point last time? If I'm dealing with means, do I have to make the decision of Z or T? And last chapter, it was a Z or T what? Interval. Now it's going to be a Z or T. And we kind of shorten that into hot test. And then how do I finish that? Or means. And then eventually we'll get proportions. Yes, thank you. I should give myself space. So yes, specify the same way we did it last time. And then what? Check it. So really, I'm doing a test instead of an interval now. Are any of my conditions that I check going to change? I still need to be able to use Z or T for means, so nothing's actually going to change here. So what's my first condition? And again, if you wrote it slightly different, write it the same way you wrote it before so that you're staying consistent. What do I put here? And if you're grabbing yours, grab your mean one because the normal part changes. And what else do I need to write there? Specify which. What's my next condition? How many options do I have because it's means? 3. What's one of them?
Stated
And what would be stated?
as a population distribution is approximate.
What's my other easy option?
Central limit here.
Which is actually checking. And then my last option that I have to go to is, and I think I said before, graph. I don't care, right? The same way you did before. Graph your histogram of values. And then I do what?
Is
And just like I did before, I think I wrote fairly symmetric on there, but really we're checking to make sure that it's,
Not extremely skewed.
I usually write strong skew and extreme outliers out of habit. If those are synonyms, it doesn't really matter. And then what?
So we can go on to symmetric.
And then my last condition,
Independent.
what am I actually checking with independent?
Capital A is greater than
Called.
10% condition.
Now that we've dealt with this a little bit, I can kind of tell you because I don't want to tell you too early. Yesterday when we did the example, I just wrote, we're pretending that each time he runs is independent, right? It could technically be given to you in a problem like that, and which means we could skip most of this part. I've seen it once on an AP exam, but I was surprised. It just flat out told you that they were independent, and so they didn't have to do this part. But choosing to do this part and do temperature condition wouldn't be wrong either. That's why I don't want. And then you said capital N what? And
It's greater than or equal to 10.
then I plug in my numbers. And then I would write something along the lines of what?
Power of these number and individuals population.
So the only word on this whole page that's different is it switched interval to test. So hopefully you're starting to see that your efforts in the last chapter or two makes a really big difference. I always have some people who try to get by the first chapter and they can't do maybe a third of the fourth step, and then they realize that we're just gonna do the same thing over and over again. So y'all have done well with that. Alright, so where do I start with what do I need for do? What symbol? X bar. And then I'm either gonna need what or what before that.
That's the signal.
What else is my sample? Now, this problem gives me something. What?
We used to do.
Now, this problem is going to give me something like one of these that I didn't have last chapter. What was the whole goal of last chapter? And we were trying to estimate what with that confidence level. So this time, I actually have a claim from you with a number. So this time, I actually am writing what the claim mu value is. So then here we went from confidence level and Z or T statistic. Now, there are 3 different options for alternative hypothesis. These 2, yesterday we called them a what? When we draw them, these 2 only have one tail, and this one has I always write that, and I'll show you why eventually. And then there was something that was given to it that we wrote down in state that would end up being a number. So those are all my number things I'm going to be dealing with in this problem. So then, equation. But last chapter it was a confidence interval, and now we're running a test. So test statistic is what we are getting when we plug our numbers into what equation? What did we do with 525 yesterday? Plugged it into the what? Z equals equation. I choose to just call it test statistic because it can be Z or it can be T, and there are reasons eventually where that can get confusing. So this is the same thing as saying Z or T, but it's a Z or T with our numbers. So what goes here? We have these options. What's going to go on top? So in general, what always goes here? In general, it is always what? Words. Standard deviation. But when we do standard deviation and we're dealing with X bars, how do we find that?
Couldn't you just use as?
So we don't know if it's this one or this one, so it could be either one of those.
Why don't we change it over square root n?
So, because just like yesterday, we went from then we use sigma, but when we switch to this, now we're doing a graph of X bars. So what is this for X bars? That equation. And so instead of doing it separate, we're just doing it in the equation itself.
Can we write mu null instead of mu? Like are they basically
Yeah.
But then we just. What is the okay, so we're looking for.
So it's like all of our dots are standard deviation, our means
So
now.
on the bottom, it's like being.
This whole thing goes right there.
So what do you call that? What it is like?
The standard deviation of your sample. Standard deviation statistic. And that's why I did it yesterday with showing we started with 1 and then went to sample name. Alright, so when we always do this, we're gonna end up finding a number. And then once we have that number, what do we do with it? What do I always visually do with that? So just a reminder from yesterday, that's only going to give me a line, but I want to shade. So how do I know where to shade? Based on your in your alternative alternative hypothesis. And then so we are going to end up comparing our p-value versus our alpha. And so from the thing that I used yesterday, we either say that it is less than or it is not less than. Remember, because I try to say all positives are all negative connotation or all positive connotation. Just write this and I'll come back to it later. We've done this. You're fine with it. It's just trying to think about it out of context.
It's less than or less.
Yeah.
Okay.
So if our p-value ends up being so small that it's smaller than what we said we would reject, then we basically do away with the initial claim. So our conclude, we actually wrote yesterday. So we have two options of what we're doing with null hypothesis. We're either going to So I'm writing this as one sentence. I'll do it separate. Like everything that we go with this is going to be on the top, everything that we go with this is going to be on the bottom. So we reject the null hypothesis that mu equals whatever number of units. And then this goes from the last thing we wrote. So our decision is all based off of our p-value versus alpha. So we do reject when it is less. We fail to reject when it is not.
Why are the p-values? This is for me.
P-value and P are very different. P-value is a shaded area.
Okay.
So again, if I go to the top, I'm saying the top the whole time, we reject the null hypothesis since the p-value is less than alpha, or we fail to reject the null hypothesis since the p-value is not less than alpha. Which means that we have two options here. If it's going to be like this, we do or do not. What's going to be on top? Do, because those are all yes. Yes, we reject. Yes, it is. Yes, we do. On the bottom is instead going to be do not. Have enough convincing evidence that the mean, whatever your alternative is in context.
Do you finish that?
That's it.
We do or do not have enough convincing evidence of the mean.
And you can say direction.
Or extension.
so it's gonna be like this one would be something like,
So then, okay.
here it would be, like we do have enough evidence that the standard deviation is not greater than 3 degrees. So like it's, you actually plug it in there. So from the court case example, this would be, we reject the fact that they're innocent since, isn't gonna make sense with this, the p-value is less than alpha, which means we do have enough convincing evidence that they are guilty, or we fail to reject the fact that they are innocent since p-value is not less than alpha, which means we do not have enough convincing evidence that they're guilty. Questions with so far?
So are they giving us alpha in
If they don't, we use 0.5, 0.05, but most of the time, yes.